Okay, what's going on today? You have, this is assignment 8A. And what we're going to be doing today is solving, they're not quadratic equations, they're cubic equations. Remember, quadratic equations are the ones where you have two answers and you label your A, x squared, B, x, and then C is a number without the x. Now the game changes. You have 2x to the third minus 162x equals 0. This is a cubic equation. Since my x is to the third power, then there are three answers I need to find. Now you're not going to label your terms with letters. That doesn't work. Okay, not when you have cubic equations. Those only work with the quadratic equations. What you do when you have cubic equations is you make sure you're equal to 0 first, okay, which you are because you have an x third and x, okay. You underline the terms, and I just made two lines. There's two terms. There's the 2x to the third and the 162x, so two terms. When there are two terms, you are going to set up two boxes, okay. One box is for the greatest common factor to come out. And then my second box is to see if I have a difference of perfect squares. Okay. Okay, now a couple things. 2 and 162 are the two numbers that I'm looking at. So I scroll down on the second page of the document. I put a multiplication chart. Now 2 is a smaller number, so here's 2. Now the chart isn't big enough to go to 162, but since 162 is an even number, I know that I would eventually get to 162. So 2 would be my GCF. And since both of these both have x, I also need to factor out x along with it, okay? Put that in parentheses. So we're going to go up and divide by 2x, because then I can cross out the x's on the second line. Now 2 divided by 2 is 1. Now x to the third divided by x is not x. Here's what x to the third x times x times x is x to the third. Then I divide by x. Those cancel, but now I have two factors of x remaining. So x to the third divided by x is x to the second. Okay. Minus. And then 162 divided by 2 should work. It means it shouldn't. It's 81. Okay, now here's what you do with the difference of perfect squares. You focus on your second parentheses, the 2x is out, okay? You focus on your second parentheses and you make two parentheses, one with a plus, one with a minus. And if you have a 1 in front of the x, you can get rid of it. If you have another number, you won't, but if you have a 1, you can get rid of it. Because we know x to the second can be written as x times x, and then negative 81 can be positive times negative. And 81 is on that list of numbers down the row. 81's here, and that's 9 times 9. Okay, so that's been factored. Now that 2x factor, you need to drop that down, okay? Now put equals 0, and you now have f1, f2, and f3, okay? So f1, 2x could equal 0. So I divide by 2, and 0 is my first answer. f2, x plus 9 could equal 0. So I minus 9. And I get negative 9. And then x minus 9, add 9 equals 0, add 9, and x is 9. So there's your answer, 0, negative 9, and 9. Okay, now my next problem. We have x to the power of 3 minus 100x equals 0. So this has three solutions. Okay, so we have the x to the third and the x, so that means we need to factor. Okay, there's two terms, so we're going to do it like we did up on top. We make a box here so I can factor out the greatest common factor. You should put equals 0 behind it. I didn't do it on the first one. GCF. Then I make a second box for the difference of perfect squares. Different, just label it DOPS, D-O-P-S, difference of perfect squares. You make two parentheses, one's a positive, one's a negative. Okay, now we're ready to go. So you set those two things up. So GCF 1 and 100. Well, 1 and 100 would just be 1, but these both have x, okay? Because the final term contains an x, so we need to factor that out as well. So I can cross it out. So I divide by 1x. 1 divided by 1 is 1. Now remember, x to the third divided by x is x to the second. Then minus, and then 100 divided by 1 is 100. Now the difference of perfect squares, okay? You're looking at that second parentheses, okay? This one here will just drop outside. Okay, you can get rid of your 1. The 1 is pointless to have in front of the x. If it's a 1, if it's another number, then you can't just get rid of it, but it's a 1. Now x to the second can be x, x, and then 100 can be written as a perfect square as 10 times 10, okay? And that 1x, right there, I just dropped that down. And now I've factored the equation, f1, f2, f3. So 1x could equal 0, so I divide by 1, and that's 0. X plus 10 could equal 0. That's negative 10. And then x minus 10 could equal 0. And that's going to be positive 10. Okay. So there we go. Okay, now my next one. We have 3x to the third minus 75x equals 0. So it's a cubic equation, so there's 3 answers. So with cubic equations, we don't do the ABC stuff, okay? We underline the terms that we have, and there are two different types of x, an x third and x. So there's two terms. And when I have two different degrees of x, x third and regular x with two terms, we need to use the GCF and then see if we have a difference of perfect squares. Okay, so 3 and 75, let's take a look at our table. Let's look at 3's row. And 75's there, it's at the end, so we can, 3 is the greatest common factor. So 3, and the last term has x. So whatever x is on this last line, that's the one I factor out. So I divide by 3x, those cancel. That's 1, and that would be x to the second minus 25. Now, parenthesize that, and that just comes down here, okay? That 3x does. Now this one here, I see, well, I can get rid of the 1 in front of the x. X to the second can rewrite that as x times x, and 25 we can rewrite as 5 times 5. And now I have my 3 factors, f1, f2, f3. So 3x could equal 0. I'll divide by 3, and that's 0. X plus 5, and that's negative 5. X minus 5, that's positive 5. Okay, and that's how you do a cubic equation with two terms. Okay, two terms, each containing an x of different degrees. By degrees, I mean that's to the third, and that x right there is to the first. Now, the next 3, Now the game changes. We have 2x to the power of 3 minus 4x to the power of 2 minus 30x equals 0. So there are 3 terms, or 3 answers I should say. But now here I had 2 terms to deal with. Here I have multiple x's. I have a third power, a second power, and a first power. Okay. So we're going to have to factor, but now there are not 2 terms, there are 3 terms. Okay, underline them. So if there's 3 terms, I'm going to make 2 boxes again, the first being the GCF. But then the second, I'm not going to find a difference of perfect squares because there's 3 terms. I'm going to make that table the T table and then decide what A equals, okay? So don't get ahead of yourself. This allows you to kind of solve it. So you have 2, 4, and 30, okay? So if you look at your multiplication chart, you go to the row of 2, 2's there, so is 4, and so is 30. So 2 is my GCF. Now look at the last line and you see x, so you have to factor out x, okay? Now go up and divide by 2x. Now 2 divided by 2 is 1. X to the third divided by x is x to the second minus 4 divided by 2 is 2. X to the second divided by x is just x. And then 30 divided by 2 is 15, and there the x's go away because they're to the same power. Okay, now your T table, you do your A, your B, and your C, and you take 1 times negative 15, and that's negative 15. So it's a positive times a negative. Remember, don't do anything with that 2 when doing the chart. You're just focused on these 3. And we have to add to get to negative 2. Now 15 divided by 1 would be 15, but that doesn't add up to negative 2. 15 divided by 2 is a decimal, so I don't put that. 15 divided by 3 is 5, and there's my negative 2. Okay. Now your A up there is a 1, so you can now get rid of your 1, and you can just make 2 parentheses. Put your x, because remember I got rid of the 1, so it's x times x, and then plus 3 minus 5. Now, that 2x right there, now at the end, goes in front. And that's important now, because there's an x now in there. We've seen ones where there's just a number without an x, so it really doesn't matter, but when that GCF has an x, we need to really focus on it, because that's my F1, F2, F3. So 2x could equal 0, so I divide by 2 and I get 0. X plus 3 could equal 0. I minus 3, I get negative 3. And then for the final answer, x minus 5 could equal 0. So I add 5 and x equals 5. So those are your 3 solutions for x, 0, negative 3, and 5. Okay, my next problem. 3x to the power of 3 minus 27x to the power of 2 plus 42x to the power of 1. I'm not going to put the 1 though. So there's 3 answers. So I have x to the third, I've got x to the second, and I've got x. So that makes 3 terms. So again, I make my GCF. Then I make my box with the table instead of looking for a difference of perfect squares, because difference of perfect squares only works when you have 2 terms. So 3, 27, and 42. So in the third row you have 3, you have 27, you have 42, so 3 is going to be the GCF. And look at your last line, you also need to take the x along with it. Okay, so you can cross that x out at the end. Okay, so 3 divided by 3 is 1. x third divided by x is x to the second. 27 divided by 3 is 9. X second divided by x is x. And then 42 divided by 3 is 14. Okay. Now I have a quadratic expression inside there, a, b, and c. So 1 times 14 is 14. Okay. Positive 14, so match the signs. So you can always switch them to positive. And we're adding to get to negative 9. 1 and 14, nope. If I divide by 2, I get 7, and that adds to negative 9. Now the a up there in front of the x to the second is a 1, so I'm allowed to now delete that, okay, and just make 2 parentheses. So x is x minus 2 minus 7. Now you can't forget about your GCF. That pulls down here. And now I have factored the expressions. So you have f1, f2, f3. So 3x could equal 0. 3 times x, you just do the opposite of times, which is divide, so you're going to have 0. X minus 2 equals 0. You'd add 2 to both sides. That gives us 2. X minus 7 equals 0. You add 7. That's 7. So 0, 2, and 7 are the 3 solutions. Okay, then my last problem. We have 10x to the power of 3 minus 34x to the power of 2 plus 12x equals 0. So we have 3 answers. So with a cubic equation, you're going to not use your ABC, you need to use arrows. You have x to the third, you have x to the second, yep, and you have x, okay? So with all 3 of those, there's 3 terms, okay? And you're going to again use the greatest common factor, and then your table. So 10, 34, and 12. Okay, now you got to look a little bit on your table because 10 is your smallest number, but 34 is not there. And I'll go find 10 again. The 5th row is the next one up, but 34 is not there. Okay, 10's in the second row, 34 is in the second row, and 12's in the second row as well. So 2 is your GCF. And you get to take an x with your 2 because you have an x on the last term. Okay. I can divide all these by x, okay? Okay, so 10 divided by 2 is 5. Now dividing an x third by an x takes it to x to the second. 34 divided by 2 is 17. Dividing x to the second by the x now takes that to x. Then 12 divided by 2 is 6. Okay, now look in the second parentheses. This is where you're looking at. You got A, B, C. So 5 times 6 is 30. It's positive 30. So negative, negative. And we're adding to try to get to negative 17. So 1 and 30. Nope. 30 divided by 2 is 15. Nope. Or yeah, that works. Now, unlike the last 2, your A is not a 1, it's a 5. So if you can't get rid of the 5, you need to make sure you factor it using 2 sets of your parentheses. That 2x right there, you'll put down here, because that's where you're going to end up. So A is 5, so we start at 5, and then x minus 2 and x minus 15. Now 5 and 2 are only in the first row, so we can divide them by 1, but that stays the same. 5 and 15 are both in the 5th row, so I'd want to divide those both by 5, and that's going to be 1x minus 3. And now we have it, okay? So F1, F2, F3. It's the same rules as before. If your A's, if it's not a 1 and you can't get rid of it, you need 4 parentheses and start with that 5 in front. So 2x could equal 0. So 0. 5x minus 2 could equal 0. So we do 2/5 because that won't divide, that's a decimal. And then 1x minus 3 could be equal 0. So add 3. You can divide by 1, it's still 3. Okay, 0, 2/5, and 3.